definitely a College Board does things to trick you kind of question, okay, is that the higher scores are more depressed, not less. And I feel like sometimes with, like, do you guys see what I'm saying there? So sometimes they'll tell you that, and it becomes really important in terms of how we kind of manage the question, because sometimes, especially with greater than or less than signs, with some of these it can get a little bit like uncomfortable. So I just wanted to kind of throw that out there. Okay. So basic idea is if you take caffeine away from somebody who needs caffeine, they go through depression. 100% true, guys. Okay. And so what I want to know, first and foremost, would it make sense to directly compare this 5 and this 16? Can we compare those two numbers? Why are we allowed to compare those? Because this is the same person. So are you guys comfortable with this idea that these are, in fact, paired data? Great. Okay. So when we have paired data, we typically calculate a difference. And in what direction do you guys want to do that difference? You want to do placebo minus caffeine. So let's go ahead and make sure. And so for each person, the actual data we're going to use, we're going to need to subtract their placebo depression score minus their caffeine depression score. So for the first person, that would be 11. The next person would be 18. 1, 4, 6, 19. You guys, these numbers are getting big for Miss Meister. Is it okay that one difference was a -1? Great. Cool, and as you're looking at these differences, did taking the caffeine away from the caffeine people cause problems? Are you sure? Why?
Mostly every number is positive.
Mostly every number is positive. Almost every number is, yeah. Lots of positives. Some are like, I don't know, a 3 could be explained by other circumstances, right? Some stuff could be explained by other stuff and not necessarily the caffeine. Okay? Hey, why did the researchers have some of them start with the placebo and some of them start with the caffeine?
To randomize treatments.
Well, we certainly want, it randomizes treatments for sure, but why is that important?
I'm sure it's not just a result of like doing one first.
It's not so much a result of doing one first. Like the goal of randomizing treatments is not about the treatments themselves. It's about the other variables that might influence the response variable. So, for example, I don't know about you guys, but I don't have a lot of depression when this is coming through my window. But do you guys remember a couple weeks ago where it was like gray for like, do you remember? We were all miserable. Like the weather genuinely affected mood. So if it was really good weather on the caffeine day and really bad weather on the placebo day, that could explain differences more so than say unless you randomize that order. But by randomizing the order, there is no placebo day versus caffeine day, because both the crummy day and the sunny day have placebo and caffeine in them. Do you guys get what I'm saying? Okay, so we want to randomize treatments, but the why we randomize our treatments is what they'd be getting to here. That's that they would want you to somehow explain that you would want to make sure external factors such as weather or like really sad news events. Imagine the day before something really sad happens the day before the placebo day. You guys get what I'm saying there? You don't want a placebo day and a whatever day, because if there's an external factor, because the days are separate. Does that make sense? Okay, so yes, our goal is to randomize treatments, but we do this to ensure the patient's reactions are how do I say this? Split. So that outside variables related to the days of the week are not a factor. And it's not that we're removing that influence. We're just equaling that influence between both groups. So now when we do see a difference, it's not because of that, it's because of other things. Lovely. All right, guys, you know what we need to do next. Carried out tests to investigate the researcher's question of, does taking caffeine away make people more depressed? And this is specific to which group of people? People who are caffeine dependent. Okay. Does anybody want to guess what our null hypothesis should be? Mu D equals 0. And my alternative? Is greater than 0. Because, well, let's go back to that researcher's question. Researchers want to know would lead to an increase in depression. So that would mean that the depression for the placebo is higher than the depression for the caffeine group. Good? We all understand why it's greater than in this particular case. And you see how they hide it all over the place. I feel like that's worth noting. Okay. And you guys, what is mu D? The true mean difference in depression ratings. And then I like to do, in parentheses, placebo minus caffeine. And you guys, if these are my hypotheses, what is the appropriate procedure? Is it a test or an interval? Test. And what can we say about our data? Where did it come from? It's paired. So a paired t-test for mu d. And you guys, what conditions are necessary for a paired t-test? Random. Was the random condition met? How?
Random sample.
Was it a random sample?
The treatments.
The treatments were randomly assigned. And that's important. Okay, normal? What's our sample size? N equals 11. Is that big enough? No, so what do we do if the sample's not big enough? Sketch your dot plot. Thanks, guys. And it's going to go from -1 to what, 29? 23? 19. -1 to 19? Is that right? So I'm just going to count by twos for space reasons. Pick my dots. And we'll call that mostly mound-shaped and symmetric. So once you put it in, you go stat, you do t-test. Guys, I don't mind if you just want to steal it from me. No, so that we, if you, I don't know where we are time-wise. What time is the bell ring?
30.
30? Okay, we got plenty of time. Everybody good? And this time the mean of my null hypothesis is 0, right?
Is it independent because
Oh, I skipped independence, thank you. Independent. Individual responses are independent. It is not the 10% condition in this spot. All right, and then from our calculators, we get t equals 3.53. The p-value is 0.0027. X bar is 7.36. S 6.92. N equals 11. Everybody good? So what's my conclusion? Since p-value, that's a pretty small p-value, yes? And with a low p-value, we can reject the null hypothesis, and therefore we can conclude removing caffeine causes an increase in depression score. Can we conclude that for everybody?
Just those dependent on caffeine.
For those similar to those in the study. In this case, who are dependent on caffeine. Bless you. What's next? 2 sample, yeah? That can wait until Wednesday. Your quiz is Thursday. Dean, did I give you new papers?